section on hyperbolas is graphing. Okay, so we're going to graph our hyperbolas today. So if you have your chart for hyperbolas on one of your other note sheets, again, looks like this. Yours doesn't look like this. This is just all of them together. But your table for hyperbolas should look like this. And you will need these equations of asymptotes today. Okay?
All right.
So, when graphing hyperbolas, your a squared value always comes first. Okay, so like when we were dealing with ellipses and we were graphing those, we had to pick which one was a and b. Well, for hyperbolas, a squared is always going to be that first denominator. Okay, and b squared will be that second one. Okay, so now, since a squared is underneath x, if I look at my chart here, we have a squared underneath x, that is horizontal. Okay, so our hyperbola will be horizontal. Okay, so next, finding the center. There's way too much talking. Finding the center, it's at h and k. H is always by x, k is always by y. So our h will be 3, and our k will be -5. Okay, so to find our vertices then, again, we're using that chart. Our vertice is at h plus a, k, and h minus a, k. Meaning we need to find a. Well, to find a, we're going to take the square root of that a squared term. So a will be 2. So to find my first vertice, I'm going to take 3, add on a, which is 2. So we have 5. And then our k value is -5. Now we have h, which is 3, minus 2. So we have 1, -5. Yep, k stays the same. Now we want our covertices. For horizontal hyperbola, our covertices are at h, and then k plus b, and h, k minus b. So we need b. So to find b, we're going to take the square root of our b squared term here, which is 9, to get 3. So for our covertices, h stays the same from our center. So we still have 3. And then we'll take our k value of -5, add on 3, to get -2. For our second covertice, again keeping h the same. Then our k value -5 minus 3 to get -8. Okay, next points we want are our foci points. Okay, your foci points are at h plus c, okay, and h minus c, okay. So to find c, we can use the equation c squared is equal to a squared plus b squared. Okay, and then I just want to plug in my a squared and b squared values. Again, you can just take those from up here. So if you happen to get a decimal for one of these, just use your whole number from up here. So we have c squared is equal to 4 plus 9. So c squared is equal to 13. Okay, we can take the square root. We're going to get a decimal. Okay, so it's about 3.6. So again, using c, we can find our foci points. So our h value is at 3, and we want to add 3.6 to that to get 6.6. And then our k value stays the same at -5. Then we're going to take our h value 3 and subtract 3.6 to get -0.6. And again, k stays the same. Now, before I start plotting these points, what I'm going to do is find the asymptote slope. Okay, I'm going to find the asymptote slope. Now, for a horizontal hyperbola, your asymptote slope is plus or minus b over a. Okay, and I have both a and b right here. So our slope for our asymptotes here will be plus or minus 3 over 2. Okay? So when I'm graphing this, what I'm going to do first is plot this center point at 3, -5. Okay, so 3, -5, it's right here. Now from that point, I'm going to use this slope. Okay, so I have plus or minus 3 over 2. That's your rise over your run. Okay, so from here I can go up 3 and then right 2. Okay, that's another point on that asymptote. Okay, so I went from my center, I used this slope, went up 3 over 2. I'm going to do the same thing, but I'm going to make it negative this time because this is plus or minus. So I'm still going to go up 3, but instead of going right 2, I'm going to go left 2. Okay, so you should see this kind of triangle here. Now with that, you can take your straight edge, if you grabbed a ruler. Okay, again, this was my center point. Okay, I'm going to connect my center and the first dot I drew there. And I'm going to make a dashed line. Okay, making a dashed line. That's one of your asymptotes. Now the second, again I use the negative slope for the second one, is going through that center point and the other point that I drew in using that slope. Okay, so these are my two asymptotes here, and they have to go through that center point. Okay, so next what I can do is plot my vertices. Okay, so I have a vertice at 5, -5, and at 1, -5. Okay, your co-vertices are at 3, -2, and 3, -8. Okay, so now when you're graphing a hyperbola, you use your vertice and you approach your asymptote, but you never actually cross it. That's why it's called an asymptote.
Oh, that's what it, oh.
You approach it, but you never cross it.
That's what
Yes.
I never knew how to spell that.
See, sometimes it helps when you understand. It's actually then you know why you're actually doing it.
Why I'm saying you had to graph them? Yeah, I was getting there.
Can you describe an asymptote?
It's a line on your graph where right. Your line approaches it, but it does not actually cross it. Okay, so that's why we wanted to draw in. That's why we wanted to draw in these asymptotes here, so I knew how far my hyperbola would get to. Okay? They're just the covertices. Okay, you can also plot your foci points. Okay, that's at 6.6 and then -5 and -0.6, -5. Okay, those are your foci points. Okay, so when you're graphing these, you do need the slope of that asymptote so that you know the general direction of your hyperbola. Okay, so your lines will get closer and closer, but they'll never cross those. Okay, any questions on my graph? Your slope, asymptote slope, is B over A. B was 3. A is 2. Yes. That is A squared. A was 2. Squared is 4. B, 9. Yeah. Other questions? Okay. So in the equation for, quiet now. In the equation for any hyperbola, the value of 2a represents the constant difference. This is the absolute value of the difference between the distances from any point on your hyperbola to the foci of the hyperbola. So any point on the hyperbola at the right will have the same constant difference. Okay, so any point here on your hyperbola will have that same constant difference between your focus and your focus. Okay? Or it's 2a. So an example of this, we're going to write out the equation of this hyperbola. So we have 2 receiving stations that are 150 miles apart that receive a signal from a downed airplane. They determine that the airplane is 80 miles further from station A than from station B. Okay, since it's further from station A than station B, this right here is your constant difference. Since we know it's further away. So we want to determine the equation of the hyperbola centered at the origin on which the plane is located. Okay? So your 2 receiving stations that are 150 miles apart would be like your foci points. Okay? So these are the distance between your 2 foci points. Now if it says it's centered at the origin, what coordinate is that? 0, 0. Okay, so that's your H and K. Okay, so next what I want to do is find A. Since your constant difference is 80, and to get your constant difference, you can take 2 times A. I'm going to set my constant difference equal to that equation. So what I'm doing here is finding A. So constant difference, 80, is equal to the equation to find the constant difference, which is 2A. So divide both sides by 2. So our A value is 40. Okay, next, since I'm given that distance between my foci points, okay, we can find C. Okay, so we're going to take that distance.
Where's B?
I'm getting there. I gotta find C first.
B comes before C in the alphabet.
I know that, but you can't find B without A and C for this equation. What?
I'm just saying. It makes no sense.
It does. You can't find B with just the foci points and the constant difference. You can find A, but you can't find B. So I'm going to take that distance between my 2 foci points, and it's equal to 2C. So I can divide 150 by 2. So C is 75. So now I can find B by again using my equation here. C squared is equal to A squared plus B squared, since I now have C and A. So plugging in 75 for C and 40 for A. Okay, 75 squared is 5,625. And 40 squared is 1,600. Okay, so I can subtract 1,600 from both sides to get 4,025. Now to get B by itself, you'll take the square root of both sides, but I'm just going to leave it as the square root of 4,025, because again, when we plug it into our formula for our equation, we have to square B and we have to square A. So that square root will just cancel out. Okay, so our hyperbola equation here is x minus h squared over, h is 0, it's right here, over a squared. Our a value is 40, so we'll square 40, get 1,600, subtract y minus our k value, again, is 0, squared, over our b squared value. When I square a square root, they cancel out, and it should equal 1. To draw in your asymptote.
There. That's just unheard of.
All right, we have one more.
I feel like we're just learning the same thing.
Yeah, it is pretty much the same thing.
Well, then what do we need to do now? We already done this.
No, we did this for ellipse, not for hyperbolas.
See, when you do the same thing,
Yeah, it gets easier and easier, doesn't it?
it just gets more easy.
No, it doesn't.
Because you're learning the same thing, but you're teaching us how
No, it's different because it's a different equation. You still have to learn how to do it. It's the same process, just a different equation. Yeah. But it'll still be a little bit different from the ellipse. All right, so with this one, we're not in our standard form. Okay, so we have to put this into standard form. So just like we did before, we want to group all of our y's and all of our x's. Okay, so I have 9y squared. I have minus 54y. Then grouping my x's, I have minus 4x squared. And I have a 32x. And I want that 19 on the other side of my equation. Okay, so now that I've grouped my y's and my x's together, I need to factor out 9. Factor out 9. Factor out 9.
Let me finish. I was about to say times 3.
Okay, I need to add something to this to complete the square. Okay, I'm going to factor out a negative 4. So I have x squared. That means this has to be minus, since I factored out a negative 4. 8x. Plus adding something on is equal to 19. Since I added 2 things, add 2 on the right. Okay, again, to get this right here, we need to take b over 2 and square it. So our b value here is negative 6 over 2 squared. Okay, that's negative 3. Negative 3 squared is 9. For this one, our b value is negative 8. Okay, negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Okay, so now I have 9 times y squared minus 6y plus 9 minus 4 times x squared minus 8x plus 16. Now I need to add on my 2 things at the end here. Since I added a 9 here, I need to multiply what I added by what's on the outside of my parentheses. So I have 9 times 9 to get this spot here, 81. Okay, and this one here, I have negative 4 times 16. So that will be negative 64. Okay, don't forget to multiply those 2 numbers together. Okay, so now I can finish completing the square here. Take the square root of your first and last term. So I have y and 3. Look to your middle term to see if it's plus or minus. And that quantity squared. Same thing here, first and last term. Look to your middle term to see if it's plus or minus. That quantity is squared. Then add all 3 of your terms on the right side together to get 36. Now for your hyperbola equation, it has to be equal to 1, just like the ellipse had to be equal to 1. So I need to divide everything by 36. Okay, and I can reduce my fractions here. So I'll end up with y minus 3 squared over 4 minus x minus 4 squared over 9 will be equal to 1.
What was different about that?
It's the same process, but you still have to do it because if you had a negative out front here, you'd have to move it to the middle because this is negative. Same process. Okay, now I can find my center point. Okay, center, H is with X, K is with Y. So we have 4, 3. Our A squared value is always that first one. So to find A, we'll take the square root of 4. That's 2. To get B, take the square root of 9. That's 3. Now since we have y over a squared, this is a vertical hyperbola. Okay, so I can then find my vertices and co-vertices. Since it's vertical, I'll have h and then k plus a and h, k minus a. So my h value stays 4. Then I have 3 plus 2 is 5. H stays at 4. Then we have k, 3 minus a is 2 to get 1. Okay, to find our co-vertices, we have h plus b, okay, and h minus b, okay. We have our h is 4 plus our b value is 3, so that's 7. And then k stays the same. Again, h is 4 minus 3 is 1. And k stays the same. To get our foci points, we need to use our equation c squared is equal to a squared plus b squared. Okay, so we have c squared is equal to 4 plus 9. So c squared is equal to 13. So c is equal to 3.6. It's the same as we did on the first problem. And our foci points are at h, k plus c, and h, k minus c. So our h value is 4, k is 3 plus 3.6 is 6.6. Okay, then we have 4 for h. Again, our k value is 3 minus 3.6, so negative 0.6. Okay, and again, when we are graphing a hyperbola, you do need the slope of the asymptotes. Okay, and since this is a vertical hyperbola, your slope for your asymptote is plus or minus a over b. Okay, and our a value is 2 and our b value is 3. So our slope is plus or minus 2/3. So I can plot my center point at 4, 3 and use my two different slopes from that point to create those asymptotes. Okay, so we have our rise first, so go up 2 and then right 3. Okay, same thing but negative this time, so up 2, left 3. Okay, and again, you can take your straight edge, connect your center to the point you just drew in for your positive slope. And with your negative slope. Okay, so these are your two asymptotes. And then you want to plot your vertices. So I have a vertice at 4, 5 and 4, 1. Okay, from here you can make your hyperbola. Again, it should round and get closer to that asymptote, but never cross it. Same thing here. Okay, and then you can just finish plotting your covertices and your foci points. So our first covertice is at 7, 3. And the second at 1, 3. And then my foci points at 4, 6.6 and 4, negative 0.6. Okay, your foci points should always be kind of inside that hyperbola. Okay, they shouldn't be floating off to the side like your covertices do. Should always be within that hyperbola.